The nervous system is divided into two major functional divisions. The somatic nervous system, which we've been talking about already at the end of A&P1 and so far in the beginning of A&P2, is mostly concerned with voluntary movement and conscious perceptions. It's a bit more complicated than that, but that's the simple gist of it. The autonomic nervous system, however, is one of two major aspects of homeostasis. This is the part of the nervous system that controls homeostasis. In the next unit, we'll be looking at the endocrine system, which is also involved in homeostatic controls. The nervous system is divided into two major functional divisions. The somatic nervous system, which we've been talking about already at the end of A&P1 and so far in the beginning of A&P2, is mostly concerned with voluntary movement and conscious perceptions. It's a bit more complicated than that, but that's the simple gist of it. The autonomic nervous system, however, is one of two major aspects of homeostasis. This is the part of the nervous system that controls homeostasis. In the next unit, we'll be looking at the endocrine system, which is also involved in homeostatic controls. By homeostasis, of course, I'm referring to processes that control the internal environment of the body. However, there's a bit more to the autonomic nervous system, and an approachable way to learn what it's really about is to start by thinking about the major functions that are associated with it. One major function is referred to often as the fight or flight response. There are other sources that will refer to this by a slightly different name, trying to be more inclusive. Fight, flight, fright, or fear, I believe, is another one, or something to that effect. We'll stick with fight or flight for this material. You're probably familiar with fight or flight. If you're faced with a threat of some sort, you either are going to stand up to it and fight it off, or run away. And the autonomic nervous system, in one of its capacities, is responsible for all of the internal physiological changes necessary for that type of response. To illustrate the fight or flight response, let me suggest this scenario. It's not a modern scenario. The idea is to address an environment where humans have spent more of their collective history or prehistory, meaning a savanna type environment. And so imagine that you see a lion, a predator that's a threat to you. With a threat like that, you could potentially do one of two things. You could stand up to it and fight it off, or you could run away. Chances are you're going to try to run away, so you'll think about where you can hide. You're probably familiar with this sensation. You can imagine under these conditions, faced with a predator, you'd be quite anxious, and you can feel that rush, that adrenaline getting into your bloodstream. The most common thing that you'd associate with a rush of adrenaline would be an increase of your heart rate. And surely with the anxiety coming in, you'd start to sweat. Maybe not just on your palms, also across your forehead. And that would be the basic fight or flight type of response. What's actually going on is a bit more complicated. The possibility of either fighting the threat or running away from it is going to require the same sorts of physiological changes. You're going to need to get your skeletal muscles working in their peak possible condition, and you're going to want to conserve as much energy for the effort you're about to exert. The increase in heart rate is going to move the blood around your body more, of course. With that, you want to get blood to the skeletal muscles, and the blood vessels will dilate in the skeletal muscle tissue itself and constrict elsewhere, especially in the digestive tract, where you don't need blood going because you're not going to be absorbing nutrients at that time. Nutrients that you'd be absorbing into your bloodstream from the digestive system wouldn't probably help too much in the immediate response to running away from the lion on the savannah. Also, your breathing's going to change, and that's, of course, to get the oxygen into your body, which the blood's going to carry to the skeletal muscles so that they can use oxidative processes to build ATP for muscle contraction. Also keep in mind that as muscles produce and burn ATP, they generate quite a bit of heat, so your body wants to try to thermoregulate, and the most obvious part of that is going to be the production of sweat. Likewise, you'd see your skin turn more red as blood goes to the skin, also to help radiate off any excess heat from your body during your exertion.